Sir, Kizar sir.
Yes, sir.
Shall we begin the session, sir?
Yes, sir. We start, sir. Yes. Good evening to all the participants. Welcome all for today's lecture series, KSRM faculty lecture series. So today's resource person is Dr. V. Lokesh Reddy, sir, professor in CSE department and dean for placements. I request Lokesh Reddy, sir, to please start the session, sir.
Okay, sir. Shall I start the session?
Yes, sir. Please share the screen, sir.
So my voice is audible?
Yes, sir, audible, sir. It's very clear.
So good evening to one and all. So my screen is visible to everyone.
Yes, sir. Clear.
So today I want to give brief introduction about steganography. So so this is outline, introduction, metrics, LSB encoding, and future work. So now we'll see what is steganography. So the word steganography comes from the Greek word stegnos. So stegnos is nothing but covered or secret, and graphy is nothing but writing or drawing something. So that's why it comes from the Greek words, that is stegnos and graphy. So hence it is called as a steganography. So the aim or goal of steganography is to embed secret message inside other messages like image or audio or video. So generally data hiding can be done in different file formats like so text, so image or audio and video. So in all these formats we can embed or hide data, so using steganography method. So this is the illustration diagram of a steganography application system. So to embed data we need some application. So a lot of applications are there like S tools, so Stegamail, so Red JPEG, Steghead, StegoShare, so OpenStego. These are all the various tools are available. Using those tools we can embed data into the cover file. So here cover file is nothing but it is an image, video or audio. So generally this is the data to hide. So nothing but this is the secret information. It may be text, image, video or audio. So finally using Stego application we can embed data. So finally we'll get the Stego file. So this is the illustration diagram of a steganography application system. So now we'll see the illustration diagram of a steganographic system, how it is to be embedded. So to embed data at sender side we need cover file, so which is nothing but a, so any, it may be image or audio or video or text, and secret message. So also it may be image or audio or video or even text also we can embed into the image. So and key also required. So finally, so after embedding that data we will get some file. That file we can call as a stego file. So at receiver side the stego file is the input. So by using stego file as well as key, so we'll get the receiver get the cover file as well as secret message. So secret message plus cover medium plus stego key is nothing but a stego medium. So this is the classification of steganography. So security systems are generally classified into cryptography. So cryptography is nothing but here using cryptography algorithms we can convert plain text into ciphertext. So using various algorithms like RSA, so DES, AES, using those algorithms we can convert the plain text into ciphertext. And this is another security system is information hiding or data hiding. So steganography is the method to embed data into other media. So generally here link stick steganography. So it is another type. So generally it is divided into two types, that is semograms. So in semograms, so it uses only symbols and signs to hide the information. So another one is open code. So in this approach, a paraphrase is used for embedding data in link stick steganography. So next one is technical steganography. In this, so these are all the various source files, that is carrier files to embed data, that is text steganography. Image steganography means here the image will be taken as a cover file, and audio steganography, video steganography, and protocol steganography. So this is the classification of steganography. Next, now we'll see what is image steganography. So generally the image file format is the most widely used cover object in steganography. So in general, image pixel is nothing but a smallest element of an image. So it is generally represented by a dot or square in a computer monitor. So pixel are represented as rectangular matrix. So the images are divided into three categories or three types. One is binary. Binary is nothing but is called as black and white, so and grayscale image, and red and RGB, red, green, blue image. So generally the binary image has only one bit value per pixel. So 1 represents the white and 0 represents the black color. So the grayscale image having 8 bits per pixel. So generally the 8 ones represents the white pixel and 8 zeros represents the black pixel. Next, third type is RGB image. So generally this is the most widely used file format. Here 24 bits per pixel. Generally, so 24 ones represents the, so that is white pixel, nothing but 8 ones for red, 8 ones for green, and 8 ones for blue. So total 24 bits. So 24 ones represents the white pixel and 24 zeros represents the black pixel. So these are the three types of so images. So that is, one is binary, so also called as black and white. Second one is grayscale, and third one is red RGB image. Next, so generally compression also required. So why? Because this, suppose before embedding you have to so compress the data. Suppose if the cover file so is some medium, so then the embedded data is a image. At that time you have to compress the image, so that we can embed more message in the cover file. So then there are two types. One is lossless compression and lossy compression. Lossless compression so will not maintain the original integrity. So nothing but the image quality will be degraded. Image quality will be degraded in lossless compression, and in lossless compression the image quality will not be degraded. So the examples are so GIF and BMP formats are that is graphics interchange format, so interchange file format, and bitmap files are the examples for lossless compression and lossy compression. So lossy compression will not maintain the original quality. That's so the image quality will be degraded. The example for lossy compression is JPEG, giant photographic expert group format. These are the two variants of compressions, that is image compressions, lossless and lossy. Next, so these are the methods used to embed information in an image. So first one is so least significant bit method, so masking and filtering, redundant pattern encoding, encrypt and scatter, algorithms and transformation. So these are the different methods. Generally the most powerful method is LSB insertion. So this can be used for so image file formats as well as audio as well as video file formats. Next, audio steganography. So in audio steganography is also we can embed the data. So nothing but we can embed data in some digital sound. So the secret information is embedded or in audio file by slightly altering the binary sequence of a sound file. So these are the some of the methods are used. That is LSB also used here. In image also used. Here also the LSB technique is used. Next one is second method is low bit coding. So parity coding, phase coding, and spread spectrum. So these are the different methods used in audio steganography. Next, video steganography. Video is nothing but it is a combination of image and audio. So nothing but it is a combination of image and audio. So that's why all the methods we can use here. So that is what are the methods applied for image as well as audio. We can also use here. By using those methods, we can embed data. So video files are generally a collection of images and sounds. Hence, video steganography is nothing but a combination of image and audio steganography. So most of the presented techniques on images and audio can be applied to video files also. So now we'll see the metrics. So after embedding data using these metrics, we can see the quality of the image. So whether it maintains the original integrity or not. So this is the first one is mean squared error. Second one is peak signal to noise ratio. So generally, which is measured in decibels. So if any image contains the PSNR value is 40 decibels and above, so means that the quality of image will not be degraded. So then bit error rate and histogram. These are all the various metrics that are used for checking the image quality. So using MATLAB, we can easily find out the MSE values, PSNR, BER as well as histogram. Next, this is the equation for mean squared error. MSE is equal to 1 by P into Q. So where P and Q are the number of rows and columns of the input image. P and Q are number of rows and columns of the input image, and X and Y are the image coordinates, and SXY is nothing but stego file. Stego is the and CXY is nothing but cover image. Here file in the sense image file. So stego image and cover image. So substituting these values, finally we'll get the MSE. Using this MSE, we can find out the PSNR. So this is the formula required for finding PSNR, peak signal to noise ratio. So 10 log 10, 255 whole square by mean squared error. So finally we'll get some value. So that value will be measured in decibels. So now we'll see what is LSB encoding. So this is the example here. So total RGB. So 9 bytes are embedding here. So following, these are the RGB encoding. So 888 come 24 bits, 24 and 24. So suppose you want to embed 9 bits. So here what is the LSB bit of first one is 0. Here, so here also the LSB is 0. So nothing but it cannot be so replaced. Then 0 1. So 0 here also 0. So no need to replace, same as it is. Here what is LSB plus 1? This one. So this is the MSB bit. So here, so 1 is here, you have to replace here 0. So that's why you have to replace 0 with 1. So next bit is 0. Here also 0. No need to change. So finally, so 0. Here you have to 1 is there. You have to replace 1 with 0 and so on. Finally, we'll get this binary format. So generally note that we have successfully hidden 9 bits of data in at LSB position, and at a cost only changing the 5 bits, or roughly 50% of bits are changed. So next, lamp and Jew. This is the compression algorithm. Using this algorithm, we can compress the image. So finally, we'll get the compressed image. So actually, this is the algorithm for embedding data into a image file. So initially, we need to embed data. We need secret information as well as cover image. So you read the cover image and the secret text message, which is to be embedded or hidden in the cover image. Next, after that, you have to compress the text message. So you have to compress the secret message to be embedded into the cover file. So convert the compressed secret message into ciphertext. Here the cryptography technique also applied. For more security, the secret text message will be encrypted using encryption algorithm. That encrypted data will be embedded into the cover file by using secret key shared by the sender and receiver. So convert next compressed encrypted text message into binary form. For embedding, so we have to convert that text into binary form, so that only we can embed at LSB position. So find the LSB bits, least significant bits of the secret message and RSB pixels, and the secret message bits will be embedded in RGB pixels. So embed the bits of the secret message into bits of LSB of RGB pixels of the cover image. So continue this process until the image message is fully embedded into the cover file. So these are the 7 steps required to embed secret message into a cover file. Finally we'll get a stego file. So for receiver side, so the algorithm is different. So input is nothing but stego image, and you have to extract the bits of LSB of RGB pixel of the stego image, then retrieve the LSB of each RGB pixel of the stego image. So continue this process until message is fully extracted from the stego image, and after that here the compression technique is applied for secret message. Here you have to decompress the extracted secret data. So using shared key, so decrypt message to get original data. So reconstruct the secret information. Finally, the receiver receives the secret information from the stego image. So this is the algorithm required at receiver side. Next, so these are the values I obtained. So by using a stego application, I embedded data. So finally, these are the different images. This is the cover image, and this is the stego image. The MSE mean squared error is 3.6791, and PSNR is 46.19, and correlation is 0.999986. So here, so cover another image is BMP file format. So after embedding, we'll get so this one, and MSC value is this one, and 49 port is the PSNR, and we can also find out correlation value. So using MATLAB. So for all these images, that PSNR value is greater than 40. So it indicates that the image quality will not be degraded. If any image having the PSNR value, so more than 40 decibels, then image quality will not be degraded. For all these images, the quality, the PSNR value is more than 40, that is 46 point something, 49, 44, 47, 44, and 42. So these are the you can also plot the histograms using MATLAB. So this is the cover image, nothing but this is the image I have taken. So by using the MATLAB code, so I plotted. So this is the RGB color histogram of cover image. So finally we'll get this one. This is so R color, red color, green color, and blue color. So of cover image. So before embedding, so this is the image, and this is the equivalent histogram. So now, so this is the stego image. So after embedding data, so we'll get some image that we can call it as a stego image. So these are the histograms myself plotted using MATLAB. So RGB color histograms of stego image. So then there is no change in cover image as well as human eye. Human eye cannot detect the difference between cover image as well as stego image. So the histograms also similar to this cover image. Next, so finally I observed all these things. So amount of embedding data in LSB in GIF is medium. So in portable network graphics medium, in BMP, so we can embed more data. So then independent of file format, so GIF supports low, and portable network graphics supports high, and BMP supports low. So these are all the stack analysis detection. So low here also very low. So it is very difficult to extract the data, so using to identify whether the image contains secret data or not. So then image manipulation also low. So percentage distortion, so less resultant image, medium in GIF, so high in PNG. So LSB, that is BMP also high. Next, payload capacity is medium, and we can embed. So high in payload capacity is high in bitmap file. So invisibility medium, and high. These are the these things I observed. Next, so generally we can enhance this LSB technique, that is steganography technique, for rich text file formats, that is HTML, PDF or other file formats, so that the data can be hidden in any type of file formats. So and as well as we can also increase the embedding capacity. So for better robustness and better data security, and in future we can also embed that is more data in the image. So in general, the if PSNR just now I have told, so is greater than 40 decibels, then it is presumed that image quality is good. Nothing but there is no much difference between the cover image, stego image. So the LSB based steganography application yields better results, and irrespective of the file formats. And also it contains various applications, that is defense and intelligence also used, and medical imaging systems, online banking, so to stop music privacy also. So and other financial and commercial purpose also, this steganography method will be used. So this is about brief introduction about steganography. So if you have anybody having any doubts, I will clarify.
Thank you, sir. Thanks for valuable information. This is now session is open for participants. So participants, if you are having any queries or doubts, please ask.
So any doubts regarding this? So my sincere thanks to Dr. M.V. Narayan sir, so Dean CRA and Kizar and other CRA members for giving me this opportunity.
Thank you, sir. Thank you.
Thank you, sir.
For your presentation, sir. Thank you, sir.
Thank you, sir.
Okay, sir. Thank you very much, sir.
So thank you,
And
Kizar.
thanks all the participants for attending this session. Okay, sir. Thank you one and all. So with this, we end the session.